So in this video, we're going to look at some additional example problems regarding the creation of arrays and matrices within MATLAB, along with the indexing concepts that we spoke of previously in this lecture. So for our first example, we're going to assume that the following 5 lines of code were executed in MATLAB, and then answer these series of 4 questions about what would happen if those lines of code were executed. So A says to specify the size of each variable defined above. B says what is the name of the operation performed in line 5. C says specify the necessary command to re-extract variable y from A, and then specify the results of indexing A colon comma 2. So let's go ahead, and I just wrote these up. We'll go in detail on this just to get some experience, and then we will actually do the execution in MATLAB, and I'll show you the concept of how to debug in MATLAB and watch these variables be created after the execution of each line. So line 1 of the code, and I'll kind of just write these in here as well. So we have some, and I'm probably going to answer more questions than we were actually asked, just to, since I don't want to keep shifting back and forth between my .cam and the actual PowerPoint. So line 1 creates a variable called x that is a valid variable name, not necessarily a good one. It's not very descriptive. Equal is serving as the assignment operator here. When MATLAB sees the beginning of the square bracket, it knows that we are likely going to be defining a matrix of which a vector is a subtype. When we have these elements entered within the square bracket, that is basically telling MATLAB how to construct our matrix. So remember that the first element always goes in the upper left corner of the matrix, element 1, comma 1. And then these commas as delimiters between actual values tell us to move in the same row to the next column. But another way that I want you to start to think about it, that I think makes it a little bit easier to understand, is it tells us to basically do what is known as a horizontal concatenation. And what that means is whenever we see a comma, we're just going to stack things in the same row horizontally. And whenever we see a semicolon, we're going to stack things vertically on top of each other, assuming that the concatenation actually makes sense from a size point of view. So whenever you're just combining individual numbers, right, that concatenation will always make sense. So another way to say this is variable x is going to be the actual horizontal concatenation, because of the commas, of the numbers 1, 3, 5. So each of these is going to occupy a double block of memory. That concept will be covered a bit more in the second lab. So basically that is the actual vector that we've created in this case. So this is a row vector. We could describe its actual dimensionality by saying it is 1. Of course, it is 1 by, since it's a row vector, and it is a 1 by 3 row vector. So here is our variable x, and it's nothing more than a row vector of 3 doubles in this case. Variable y is going to be the same thing, right? It's just going to be 1, 1, 1, stored in this fashion. And there's nothing special if you're wondering, like, well, why is Henry showing us the actual kind of elements of memory in this case? There's nothing special about that notation. Sometimes if you take a particular instructor for your introduction to programming course, this is a notation that they will use, but you don't have to worry about this. But the idea being that this is just showing that this is an array where there's some logic in the allocation of memory, that these are stored adjacent to one another. And remember that they might not necessarily be, because memory kind of, when you define a variable and place it into memory, where it actually goes is abstract to the programmer, particularly on these high-level languages. In contrast, when we define the variable c here, notice that it is also going to be a matrix, particularly in this case a vector as well. But since the delimiters are actually semicolons, that means that we're going to stack vertically. So semicolon corresponds to vertical concatenation. So I'll just write a bunch of 2s on top of each other. So this is z, and if you notice, again, it is a column vector since it was concatenated vertically. So it has 1, 2, 3 rows, and it is only 1 column. And be prepared to answer questions about both the size of variables that are created, along with the actual whether they're row or column vectors on the actual homework and test. So question 4 here. How are we going to redefine, basically write over the variable z? We're going to redefine z as the prior value of z with this actual apostrophe. So remember that apostrophe is one way to actually write the transpose of a matrix or vector. Transpose, did I spell that right? Transpose, there we go. So if z was a column vector, when we take its transpose, we're just basically going to swap the rows and the columns. So that one column will become a row. So now that is going to make z into a row vector. So I'll just write it like that. So again, 3 by 1, when you take a transpose, it becomes 1 by 3. So now this is your definition of z in memory. And I'm writing a little line through it to distinguish it between the 2s. This is your definition of x. This is your definition of y. Now, what is actually going on in A here? Now, that's why I kind of encouraged you to think of the delimiters, commas, and semicolons. Now that we've did quite a few examples associated with forming matrices and vectors in MATLAB as concatenations. Really, now what you can see is, even though x isn't a single value, it in itself is a row vector in this case. What this semicolon is telling us to do is to basically concatenate vertically. So take x, which is 1 row by 3 columns, put it on top, then take y, and since it is a actual semicolon, we will do vertical concatenation underneath. Remember that y is just the value 1, 1, 1, and then z after the transpose is just going to be 2, 2, 2. So this is how we're actually going to form A in memory. And if you notice, this is just going to be a 3 by 3 matrix. So let's go back and just make sure that we answered all the questions that were asked for. I know we didn't because there's an indexing question, but specify the size of each variable defined. We did that. What is the name of the operation performed in line 5? Since we're taking a bunch of row vectors and we have the semicolon delimiters, this is called vertical concatenation. We're stacking a bunch of rows on top of one another vertically. Specify the necessary command to re-extract y from A. So if you notice here, y was actually stacked in the second row of this matrix. So if I want to extract an entire row of this matrix, what I would do, so to re-extract y from A, I basically need the entire second row of A. And how would I get that? Well, remember that when you index in a matrix, the first actual argument that you put within parentheses is the row number. So you want row 2. And then which element do we want within row 2? Well, we want all of the columns. We want all of the elements in with the row 2. So the actual operator that we use to indicate that we want all of the actual columns in this case is just going to be the colon operator. So that's what we would need to do in that case. And then for question D, specify the results of indexing A colon comma 2. So let's talk about that here. Open that back up. So A colon comma 2 is going to mean all rows, since we have a colon in the row place. And then this is going to mean the second column. So if I take all rows in the second column, here in the second column, I have 3, 1, 2. All rows just moves all the way down that column. So what I'm going to get is just basically a column vector. It is going to be 3 by 1. And that is what it's going to look like. So let's go through and actually verify all of this in MATLAB. And I have that open here. And I'm just going to open a new script I've already done. If you forget how to do that in MATLAB online, just click on the new button here. But let's actually just redefine all of our commands. In fact, we can probably copy and paste, but we're going to have to, obviously, we're going to have to make some editing here. We need to get rid of the line numbers and so on. And then sometimes the delimiters don't copy correctly, but we won't know until we try. Usually it's the apostrophes that tend to have an issue. So all you have to do is delete it and then retype it. It's just additional text is being copied when you actually try to zoom in here, Control plus, where we at? There we go. Additional text is being copied when you copy it over from like an XML program like PowerPoint or something. So if I save this, and maybe I will call it just example and matrices, even though that's not a very descriptive name. Now, if you want to see what's actually happening in the workspace when you execute the code, what you want to do is go here to your line numbers, left click, that will put a breakpoint on that particular line. And then when you run this script by either clicking the run button or typing the name of the script, notice that it will terminate the actual execution on that breakpoint. So here it's saying it's paused execution at line 1. What you want to do then is hit the step button. So notice now it hasn't executed line 1. When you hit step, it will. That will put into memory, as indicated down here in the workspace, a 1 by 3 actual row array where each of the elements is a double type variable, and the elements are 1, 3, and 5. If you hit step again, that will define another row array or vector, 1 by 3, with the elements 1, 1, 1. And hopefully no one is confused by what I mean by the class of this being double. That basically means how many bits are being reserved to store each of these values within your array. When I step again on line 3, I'll define z. When I redefine z, notice z is 3 by 1 before I've executed line 4. It is a column vector. When I execute line 4, the transpose operation will make it a row vector as well, 1 by 3. And then line 5 will basically do a vertical concatenation of those 3 row vectors and make a 3 by 3. which it did here. Now, the question that we wanted to, and I will just say step again, which will end the script. We were curious what would happen if we did A2, comma, colon. Our hypothesis was that this would allow us to re-extract y. Remember that the elements of y were 1, 1, 1. That is the case. It is a row vector. And then we guessed that if I executed the indexing command, a colon, comma 2, that would basically just give me the second column as a column vector. And that's exactly what that did.